They can ask you where they give you the perimeter, and you have to kind of work backwards in some parts. All right, last one. This one's a fun one. Find the area of the shaded region. All they give you. Again, we're assuming this section's on regular polygons, so I'm going to assume that each of these is regular and that this triangle is also regular. Okay, so it's a regular hexagon, and inside that hexagon is an equilateral triangle. Okay, and all they give you is that one of the sides of your hexagon is 12. So what do we do? Well, first we want to find the general concept is find the area of the hexagon. That's a hexagon, by the way, and subtract the area of the triangle because we want to remove the triangle from the shape. So if I want the area of the hexagon, you should kind of be able to do this on your own by now. The area of the hexagon, again, is 1/2 AP. Right? It's 1/2 AP. So what do we do with that information? Well, what we need to do is, and in fact, I want an exact answer here because I'm mean, and that's what I do. Which means you can't use trig, you have to use special right triangles, and I'll show you where those come into play. 1/2 AP and then minus the area of the triangle, right? Okay, so let's look at this picture here. If I draw, to the center and to here, it forms a central angle, right? It forms a central angle of what? 360 over 6, which is 60 degrees, right? So my central angle here is 60 degrees. So when I cut that in half, it's terribly drawn. When I cut that in half to form my apothem, then it makes two different 30-degree triangles, right? Two different 30-degree triangles. So then what I need to do is by cutting it in half, I also know that this side length up here is 6 and this side length here is 6 because it bisects the side length, right? So I know that the short leg of this 30, 60, 90 triangle here, the short leg is 6 because it's opposite the 30. And I need to know what the long leg is, right? I need to know what A is, which is here. I need to know what that is. Well, the short leg and the long leg have a relationship on a 30, 60, 90. To get from the short leg to the long leg, you just multiply by rad 3, which means A, or the apothem, is just what? 6 rad 3. Well, what's the perimeter? Well, if one of my side lengths is, let's do it in blue here. If this side length is 12, and I have 6 of them, then the perimeter would just be 12 times 6, right? So the perimeter is, what is that, 72? Right? So then the area of the hexagon is just 1/2 6 rad 3 times 72, which is, what is that? That's 3 rad 3 times 72, right? All I did was multiply the 1/2 and the 6 here. I just multiplied those together, okay? So I have 3 rad 3 times 72, which ends up being 200, oh, that's a circle, 216 rad 3, units squared. But that's not it, right? That's just the area of the hexagon. Now we have to figure out the area of the triangle. So I'm going to erase a lot of the work we did on here so that, oh no, I erased part of the triangle too. That's not good. All right, I'm going to redraw this on. Okay, we need to find the area of that triangle. Okay, we need to find the area of the triangle. So what again do we know? We know this is 12. What does that do for us? What does that do for us? Well, again, if I draw, it's kind of a similar strategy. If I have my central angle here from the center, if I form that, well, it forms a part of this triangle, right? So this segment here is a part of that triangle. Do we know what that segment is? Well, we do not. But again, going back to what we had before, we know this cuts it into a 30 degree. We know this is 6, which means the hypotenuse is twice the small leg, right? Twice the short leg, which is 6. So then twice that would be 12, right? Twice that would be 12. So I know that the radius of this is 12. So if the radius of this is 12, then what can I do? Well, I can do lots of things, in fact. I can now go to this triangle here and find the area of that. right? I know that this side length here is 12. I know that what type of angle is this? Well, if I drew my central angle here, I would do 360 divided by 3, which is 120, right? So this central angle here is 120 degrees, which means when I cut it in half, I get 60 and I get 60, which means again I have a 30, 60, 90 triangle where the hypotenuse is 12. So if the hypotenuse is 12, then what is the short leg? Well, the short leg is just half the hypotenuse, right? So the short leg is, and I'm going to redraw this triangle down here so you don't get super confused. So I'm drawing this triangle, this big one. In fact, I'm only going to draw half of it because it's easier. I know this is 30. I know that this is 12, which means my short leg is 6, and my side here is 6 rad 3. So if I find the area of that, 1/2 of the base times the height, which is 6 times 6 rad 3, which is 36 rad 3, which means I get 18 rad 3 for that little triangle. Well, how many of those triangles are there? Well, there's one here, there's one here, there's another one here, that's 3, that's 4, that's 5, that's 6. So I'm going to multiply that by 6, giving me what? The area of the triangle is, let's see here, 6, I forgot what 6 times 18 is. 6 times 18 is 108, right? So I end up with 108 rad 3. Which means if I want to find the total area, all I have to do is subtract there, leaving me with 108 rad 3 units squared. Okay, so those are kind of the videos there. We'll look at more of these in class. I know it can be a little challenging. But anyway, that's all we have for today. So, yeah, have a good one. Thanks, guys. Bye.